All right. Praise Jesus. Hang on, I'll see if we can get this to work.
Hey, Chief. We're expecting more than one car, correct? I am not aware of that. No worries. I got 310 of their car coming to the front gate right now. Coming in hot. It's that fucking car bomb.
All right.
I'm gonna shoot this guy, Ron. I'm gonna shoot him in the face.
Yeah, 1 2 1 2 1 2 1 2 1 2 1 2. All right. Okay. It's story time, ladies and gentlemen, little boys, little girls, and Albanese. This is a book. It's called The Universe. I think it's like grade 3 students. But because you believe in climate change, Albanese, I'm going to read it for you. All right. It's called The Universe. It's got pictures and stuff because you might need the pictures, Albanese. You all keep talking about scientists and how they tell you that the climate is warming and stuff. And I'm here to tell you, you're full of shit. You're a bunch of lying scammers, and you should all be chucked in jail for deceiving and fraud. The universe. The ultimate guided tour of the cosmos from the fiery mass of the sun's core to the Milky Way. Okay? The universe. The ultimate guided tour of the cosmos from the fiery mass of the sun's core to the Milky Way. So, yeah. Let's see. Discover the secrets of the universe. Using stunning illustrations and cutaway diagrams, the universe takes you on a fascinating journey through space and explores how the universe was formed, the evolution of stars, our solar system, and beyond. This magnificently illustrated edition also examines the spirit of space exploration and how, thanks to scientific and technology advances, like this book has even got Darwin's crap in it that's been debunked. But this is how you can use their own crap against climate change people. It's awesome, man. Introduction. Stuff that we don't need the introduction. What is the universe? The universe is everything that exists. Ooh, from the smallest to the very largest particles, combined with all existing matter and energy. This includes both visible and invisible objects, such as dark matter, the cosmos' greatest secret component. The search for dark matter is currently one of the most important tasks pursued in the field of cosmology. Matter literally determines the density of all of space, and it could also be claimed the future of the universe. Did you know that since the universe was created almost 14 billion years ago, it has not stopped growing? The question that astronomers ask themselves and what most concerns them is how much longer will it continue to grow, like I've learned, until it turns into something cold and dark. Radiography of the cosmos. The moment of creation. The transparent universe. Like it goes through like what four spaces even like made. The forces of the universe. General theory and relativity. The main contributions to understanding how the universe works were formulated by Albert Einstein in 1915. Einstein thought of space as being connected to dimensions that nobody had previously considered: time and gravity, which is Newton was the force that generated the attraction between two objects, was proposed by Einstein as the consequences of what he called the space time curvature. According to his theory of relativity, the universe is curved by the presence of objects with different masses, and so gravity is a spatial distortion which establishes that one object pulls towards another, depending on whether the curve is greater or smaller. Oh, a bit like when the Earth goes around the sun. Oh, it's even explained here. Look, look, it's got pictures for you, Albanese. Got pictures for you, Albanese. Little kid's book. A kid's book, Albanese, showing you how space works. Gravity. Okay, gravity. The first to separate itself from the original superforce, it is an attraction force that is currently perceived as set out by Einstein as an effect of the space time curvature. If you were to think of the universe as a cube, the presence of any object with mass would generate a deformation, and that cube gravity has the special feature of being able to act from a significant distance, like electromagnetism. However, it always exerts an attraction force. Okay, universal gravitation. Gravitation, proposed by Newton, is the mutual attraction between two bodies of certain masses. Newton's law and paradigm accepted until Einstein's time did not take into account either time or space as an essential part of the interaction between two objects. Attraction was caused by mass. Objects with a greater mass attract objects with a inferior mass, and this was attributed solitary to the intra intrinsic nature of objects. Nonetheless, the law of universal gravitation was the pillar of Einstein's theory. So that's why the sun goes around, the Earth goes around the sun because the sun is bigger, has bigger pull a, a bigger mass. So it pulls all the planets around it. Okay? So the planets are going around, they either go in or out. Nuclear force, how it is formed. Blah blah blah. If I have to teach this to you, and Albanese, you can go pick up a book yourself. I'm just trying to get to the bit how Earth is formed, the evolution of stars, nebula, massive star, um, the sun, Earth, red giant sun, blah blah. Six band, the future of the sun. Like any typical star, the sun fuses hydrogen. It will take another 5 billion years to exhaust its reserves. Only then will it become a red giant. Its luminosity will multiply and it will expand until it swallows Mercury and even Earth. Oh, oh. So, how's climate change got anything to do with us when the sun expands, you gooses? Gee, it just said it in my children's book. Come on, man. Yeah, I'll read it for you again. The future of the sun. Like any typical star, the sun fuses hydrogen. It will take another 5 billion years to exhaust its reserves. Only then will it become a red giant. Its luminosity will multiply, and it will expand until it swallows Mercury and even Earth. Once it stabilizes, it will remain as a giant for 2 billion years until it turns into a white dwarf star. Because they look at other galaxies and see where they're at. You understand that? White dwarf star, here you go. After experiencing a period as a red giant, the stars like the sun lose their outer layers, giving rise to the planetary nebula. At its heart is a white dwarf star, an extremely hot 1000 degrees Celsius. or 100 something, like 100/000 degrees Celsius. And dense object. When it completely extinguishes, it becomes a black dwarf star. So it's a white star and it just goes into nothing. Planetary nebula. Like these are like stars that have just exploded, and there's all the colors of left, like the particles left of it. Yeah, eventually our galaxy explodes. Like, supernova. Here you go. Supernova. Albanese supernova. Supernova. The explosion of stars towards the end of their lives is extraordinary. There is a sudden increase in their brightness, and as an enormous release of energy, this is a supernova, and it releases in just 10 seconds, 10 times more power than the sun releases in its entire life. After the star detonation, a gaseous remnant remains, and this expands and shines for millions of years throughout the galaxy. It is estimated that two supernovas explode each century in the Milky Way. There you go. Supernova, fusion, supergiant, explosion. The star ends its life with an immense explosion. In the weeks following the explosion, the supernova continues releasing large amounts of energy. Sometimes the amount of energy released is greater than the energy released by the galaxy to which it belongs. Its brightness can illuminate the galaxy for weeks. All right, what else we got? Black holes. There you go, another one. Black holes. Autonomy of the galaxy. Active galaxies. The Milky Way. The Sun and the rocky planets. The solar system. No, we're not going to worry about that. The Sun. Sunspots. Where is it? I wonder if it has it here. Solar flares, and here you go. Solar flares and protuberances released from the solar atmosphere and are capable of interfering with radio communication on Earth. Mercury, Venus, Mars. Oh, they missed the gas giants. How did they get past Earth for? Makes no sense. They put pretty sure that's a Earth there. Hang on. Oh no, hang on. You got all the other planets. You can learn to read Albanese so you can learn about the planet. Pluto, distant worlds, Oh, here we go. Asteroids and meteors. Since the time of since the time the solar system began to form, the fusion, collision, and breakup of different materials has played an essential role in the formation of the planets. These small rocks are a remnant of this process. These small rocks are a remnant of this process. They are witnesses that provide data to help the understanding of the extraordinary phenomena that began 4.6 billion years ago on Earth. These objects are associated with episodes that would later would influence evolutionary processes. The nature of meteors. One of the main goals in the study of meteorites is to determine their makeup. They contain both extraterrestrial gases and solid. Scientific tests have made it possible to confirm that in some cases the objects came from the moon or Mars. However, for the most part, meteorites are associated with asteroids. Type of meteorites. Aerolites, notable for their olivine and pyroxene content. This category subdivides into chondrites and non-chondrites. Chondrites, whatever. Iron meteorites, abundant in iron nickel compounds. Uh, see, is this even worth explaining when these are basically meteorites that they've found on Earth? And I'm telling you, they come from space and they smash into Earth. And I'm a Christian who believes God is outside time and space. Asteroids. Asteroids. Fragments of rock and metal in a variety of shapes and sizes that orbit the Sun, most over 1 million, are located in the main asteroid belt between the orbits of Mars and Jupiter. Others circle in orbits close to the Earth. The Amma, Apollo, and Athene groups or share their orbit with Jupiter, the so called Trojans. In reality, the asteroid belt is not as densely packed as depicted. So there you go. There's a planet that has rocks just going around it. And you're just swinging out and smashing into our planet. Oh, but climate change. Comets. Oh, here we go. Comets. Comets are small, irregular shaped objects measuring just a few kilometers in diameter that are usually frozen and dark in color. They are made of dust, rock gases, and organic molecules, rich in carbon, and can be formed orbiting in the Kuiper belt or the so called Oort cloud. However, many deviate towards the inner part of the solar system, assuming new paths when they warm up. Their ice formations sublimate, forming their heads and long tails of gas and dust. Okay, head comprising the nucleus, the coma. The front part is known as the point of impact. Core, frozen water, methane, and ammonia. Heat, the enormous part contains powered silicates, covering the nucleus, comprising gases and dust released by the nucleus. Envelope, layers of hydrogen that are capable of forming a third tail. Tail of dust, tail of ions. So these things just float around our galaxy. It's just like like it's just what does it say? Frozen and dark color, made of dust, rock gases. This is dust and rock all forming together, going around a planet real fast, and it just forms a comet. Imagine if they smashed into Earth. It'd be going that fast. It just smashes to pieces. Uh, here we go. Earth. Do they say anything about it on here? Slightly flattened towards the poles and widened around the equator. Earth is known as the blue planet. Yeah, blah blah blah. Do they say anything about the northern pole? Oh, here we go. Gravity and magnetism. Earth possesses a powerful magnetic field produced by its outer core, where the turbulent currents of molten iron generate electric and magnetic fields. Magnetism changes direction as time passes, allowing the magnetic poles to flow. Hmm. Do you know anything about magnetism, Albanese? Its consequences: the magnetic field protects the Earth from solar winds. Certain particles attracted towards the poles. Yeah, it's nice, eh? condensation, evaporation. Yeah. The biggest one that you need to learn about our planet is gravity and magnetism. You lose that, we're dead. Magnetism is from the poles. All that crap they tell you about the poles being melted, no, or we'd lose magnetism and we'd all fry. You hear what it just says? Earth possesses a powerful magnetic field, right? And it says here, Earth's magnetic field is created by convective currents in the outer core. Its consequences. The magnetic field protects the Earth from solar winds. What are solar winds? Come from the sun, right? So they don't burn our planet, right? Solar winds. So we're protected by this magnetic field that stops it. So our planet doesn't burn. So shut up with your climate change. The only way climate change will ever become effective, and it'll be too late anyway because your poles are just going. And I mean, they've already done enough research on the poles. The poles are fine. Structure of the Earth. Here you go. This is one for you. Earth is made up of different layers which turn are made up of different elements such as iron, nickel, and rock in solid and in liquid form, in addition to fresh water, salt water, and air. A cloud of gas encompasses our planet. The atmosphere, one of these gases, oxygen, allows the planet to sustain the majority of life. Inner layers. We live on a rocky surface comprising, for the most part, oxygen and silica. Underneath, there is the mantle. The rocks here are much heavier. Beneath the mantle are the inner and outer crusts. The former comprises constantly boiling liquid metal. The latter, which is solid due to the effects of pressure, is the densest part of the planet. So here you go. You got exosphere. The atmosphere is over 700 kilometers thick. There you go. You got the exosphere, the thermosphere, the mesosphere, the stratosphere, traso, troposphere, hydrosphere, and lithosphere. Then you have the outer mantle, the inner mantle, outer core, and inner core. And they've even they've predicted, they reckon, how big it is. Inner core, comprising the same metals as the outer core, but unlike the layer that covers it, and despite the extreme temperature, the center is solid due to the enormous pressure the center is solid due to the enormous pressures exerted on it, causing it to compress as a result. Article liquid and made up of molten rock. Oh, liquid and made up of molten iron and nickel. Its temperature is lower than the inner core and it withstands less pressure. The, mo- the movement of the boiling liquid is responsible for the magnetic field. See, it's deep. The field goes deep so our planet doesn't explode. Inner mantle. The intermediate layer between the core and the crust. It is solid and spreads temperature waves as it is close to and in contact with the core. Outer mantle. Due to the high temperatures, the materials dilate and generate a continuous rising movement that creates convection currents and the force that causes changes to the Earth's crust. Hydrosphere and lithosphere. The lithosphere houses the crust and the upper part of the mantle. The hydrosphere is home to water distributed amongst the five oceans, lakes, and rivers. There you go. There you go. That's yeah, like climate change is the biggest load of crap ever, man. You have to know your planet, man. We have a core in the middle of it that's burning. And the inner, like, what is it? The inner mantle, right, is the thing that holds the um. No, it's the yeah, it's the outer. Where is it? Yeah, I read it here before. Yeah, it's the outer core. The outer core of like the core, you have an outer core of that. That's the thing that protects the magnetic field so we don't fry and burn. And then you've got the inner mantle and the outer mantle. Like go burn your planet because there's no such thing as climate change. It's crap. It's the biggest load of crap ever. The atmosphere, the brief history of Earth, see if you read, they believe that like Pangaea, Pangaea was the formation of Earth, and they reckon it was all one island. Like just and then there was the water, like the water was in and out of it, but it was all together the Earth, and then it slowly spread apart because they have Darwin's theory, but Darwin's theory breaks. It breaks because platelets don't can't live outside the body. Plates can't live outside the body; they die. So evolution is flawed. I'm sorry. God made us. I know a lot of people don't want to believe in God because they have a lot of sins and they just want to die in their sins and not have to face judgment on their sins. I just pray that you change, man, because Darwin's theory is flawed, man. It's dog shit because you can't evolve animals if they have to eat to survive. If they have to eat to survive, they will die if they didn't know what to eat. You have to know what to eat to survive. I'm sorry, man. You can't just walk around, oh, and then just, yeah. So, in the name of the Father, the Son, and the Holy Spirit, let's continue. Planetary movement. Yeah, I'm kind of done because the moon and tides, like, it's making me tired just talking about it. But yeah, it's the biggest scam ever. Climate change is the biggest scam ever. So praise Jesus. In the name of the Father, the Son, and Holy Spirit. Peace out. Lots of love. Love you all.